Hi there. So in this video, we're going to have a look at factorizing monic trinomials. Now, just in case you're unaware, a trinomial, tri meaning three and nomial meaning number, a trinomial is when you've got an expression with three terms in it, like this one here. And typically, in a polynomial, we're looking at a squared term, and then a linear term, and then a constant term, no variable in it at all. So that's a typical one. Now, the monic part of it is when a is equal to 1. Okay, so in other words, the x squared doesn't have a coefficient. So let's have a look at, I've got two examples to go through. So I'll just zoom out so you can see them. And let's get stuck into example 1. Now, there are a bunch of ways that you can solve a monic trinomial, or factorize, I should say. So if this way doesn't speak to you, if you're not too sure about it, then just yell out and I will, I can certainly provide you with a brand new way of looking at it. So I'm going to use the reverse box method. It is useful, even if you don't like it, it is useful to master this method, because when we do more complex factorizations later on, this method is really powerful. So what we do is we take the squared term and we place it in the top left-hand corner of the box, and we take the constant term and we place it in the bottom right-hand corner of the box. I usually put the plus next to it as well because it's kind of useful to see. So the first term and the last term. Now we're going to do two things. Number one, we're going to come up with a value here and a value here, which when added together gives me this middle value here. And we are going to fill out the edges of our box here with values that will multiply up to these values and these values as well. I'll show you what I mean. I'll put an x here and an x here because x times x is equal to x squared. The next thing I'm going to do is I'm going to break down 12 into its factors. Now, you can list them in your head, list them over off to the side, or just do it randomly. But I'll let you pause it for a sec. And just for this exercise here, list down all the factor pairs that you can think of for 12. So pause the video. Okay, hopefully you paused the video. Let's see how many you came up with. I hope you came up with 1, 12, 2, 6, 3, and 4. And then they're just the same backwards then after that, which is not necessary at the moment. So if you got those three, that's as expected. But did you think about these ones? Now note they both have to be negative, because when I multiply two negatives together, I get the positive. So these two have to be negative, these two have to be negative, and these two have to be negative, and you will get that positive value. So there are in fact 6 factor pairs for 12. Now, next thing is to choose some of these factor pairs. And if you've listed them all, you can probably see the ones that you need to go for. But a little bit of smarts at the start will help you a little bit. So you've got a minus 7x. So that tells me straight away that using 2 positive factor pairs is not going to be useful. So I can sort of get rid of those 3, and then I'm dealing with these 3 as well. So imagine this wasn't here though. I would be going like this. Well, I could try minus 1 times minus 12. That would give me minus 1 times minus 12 is positive 12. That works okay. But then if I multiply x by negative 1, I get negative x. And if I multiply x by negative 12, I get negative 12x. And then if I add these together, I'd get negative 13x. So that doesn't work. And so you can sort of keep on doing that until you work out the correct pair to choose. There's not that many in this instance, so that's pretty good. But that's basically what you do. Trial and error until you get it. But with practice, you'll be able to step back from the problem and be able to go, oh yeah, I can see it would be, in this instance, minus, sorry, I'll better draw here first to make more sense. It would be minus 3 and minus 4, because x times minus 3 is minus 3x, and x times minus 4 is negative 4x. And if I look up that way, if I'm adding across, So I'll just do a little blue dotted line so you can sort of see that I'm adding across here. Then you get your minus 7x. Okay, so that fits the whole pattern. And then it's a matter of reading the sides for your two factors. So we've got, I'll just put it down here just to save me writing it out again. So that's equal to the first factor, which is x minus 4, multiply the second factor, which is x minus 3. And remember, it doesn't matter which order you multiply things together in. So if you'd written x minus 3 times x minus 4, that's absolutely fine as well. Okay, I'm not going to spend any more time on that one, but I hope that makes sense. We'll have a quick look at example 2, which at first blush does not look like a monic trinomial because the value of a is 3. And if you saw that, very well done, you're right. But remember what I said in the previous video. When you come across an expression or like this, then the first thing you should do always is look to see if there's a common factor. And if you look at the coefficients here, 3, 15, and 18, you can see that 3 is a common factor. So I've got 3 outside of x squared plus 5x plus 6. That's our slightly factorized expression. And then to fully factorize it, we would then need to look inside the bracket here and to see if we can factorize that even further. And the answer is yes, we can. I'll just draw the box method across here, put my x squared here and put my 6 here. And I've got x times x, so that's fine. And I'm looking for values that will multiply together to give me 6. That will add together to give me 5, since that's what I need across here. So I'm just going to shortcut for the purpose of this video and go straight to the factor pair that works. But if you can't see it first of all, then you'll just keep on trying different pairs of numbers until it works. So this is x plus 3 and x plus 2, because 3 times 2 is 6, and then I've got 2 times x, which is 2x, 3 times x, which is 3x, and that would give me my 5x in the middle. And so this would equal 3 multiplied by x plus 3 multiplied by x plus 2. Again, the order of those factors doesn't matter. Okay, so just be mindful of that sometimes more difficult problems aren't so bad, because if you factorize them first with a common factor, the resultant problem is much simpler to solve. I'll leave it there and have a go at exercise 3B, questions 7 and 9, and see how you go.